All right, guys. So I don't have my microphone right now, so sorry if there's any feedback or background noise. But what we want to do right now is we want to continue looking at functions and specifically finding the domain and range of a function. Uh, Here we have a nice little function, and we want to find its domain and range. We can really do this two ways. We can do it graphically and algebraically. I'm going to show you both ways. But first, I'm going to show you algebraically because we need to think about what this is. So here, in terms of what this function is, we can see that it's a square root. Y is the square root of this. So we can actually find the range, which is going to be the y values first, and that's going to be a little bit easier because the range is the y values, which is a square root. Square roots can only be positive numbers or 0. So that means that here, for the range, y must be greater than or equal to 0. There's no way for me to take a square root of a number and get a negative answer. Now, some of you guys may be thinking, well, what about the square root of 25? I made a big deal in class that the square root of 25 is plus or minus 5. If we want to take a negative square root, they would actually give us the sign in front of the square root sign. They would have plus or minus. But because there is no plus or minus here, we have to assume we are just working with the positive square roots. So for example, the square root of 25 would just be the positive 5 value. So that means that range must be y is greater than or equal to 0. We're going to use that interval notation. So because y could be 0, we're going to start with a bracket and a 0, and this is going to continue on to positive infinity with the parentheses. That is our range. Domain, we're going to feed off of the range to work with the domain because the domain is the x values. And what can x be? Well, if y must be greater than or equal to 0, because the square root must be greater than or equal to 0, that means that what is underneath the square root must be greater than or equal to 0. So for example, I can't take the square root of a negative number. Let's say, for example, x is 0. If x is 0, then I have the square root of 0 minus 2, which is the square root of negative 2. That's imaginary. That is not a real number, so that's not going to work. So we need to have it so that what's underneath the square root sign is greater than or equal to 0. So we write a little equation here. X minus 2 is greater than or equal to 0. And we solve for x. So now we find out that the domain is x is greater than or equal to 2. So again, we're going to use our interval notation, and because x can be 2, we use a bracket, and we start with a 2, and again, we go to positive infinity. And that is our domain and our range. Now we can also solve this graphically. I should not have done that. All right, let me move this graph. There we go. Okay, we can also solve this graphically. So let's do that. And I'll use blue again here. So what we would want to do is make a table of values. We want to start with our x's and our y's, and we want to find some values here. So again, we would be able to see, or we should be able to see, that for our x's, we have to start with 2. And if we have x is equal to 2, we're going to have 2 minus 2, which is 0, and the square root of 0 is 0. So at x is 2, we have y is 0. I could plug in, 3, 4, 5, 6, but if I plug in, say, 5, I'm going to have the square root of 3, which is an irrational number. I can still estimate by graphing, but I want to stick with whole numbers. So I'm going to aim for numbers that are going to give me a perfect square. So for example, 3 is not a perfect square, but when I plug it in, I get the square root of 3 minus 2, which is 1. And the square root of 1 is 1. So at x is 3, y is 1. Now the next perfect square after 1 is 4. So what do I have to have x be so that I have the square root of 4? X must be 6. So when x is 6, I have 6 minus 2, which is 4, and the square root of 4 is 2. So 1, 2, 3, 4, 5, 6, up 2. And then the next perfect square is 9. So x must be 11, which is off this, but 11 minus 2 is 9. Square root of 9 is 3. So there we go. We have our nice 0 squared, 1 squared, 2 squared, 3 squared. And that would be about there. And we'd have a graph that looks like this if I connect the dots. Looking at this, we can tell what the domain of the range is. There are no y values down here. None at all. So that means that our range must be from 0 to positive infinity, because starting at 0, this is going to go up and up. Now granted, this is going to go up very gradually. So in order for us to get some larger y values, we're going to have to get some really large x values. But we're still going to get there. It's going to go up and up and up eventually. For our domain, we can see, I put the arrow there, it's going to keep going. As long as I'm taking square roots of positive values, I'm going to have something that's going to be in this function. Whereas we stop here, and again, because we can't have a square root of a number and get a negative value, and we can't take a square root of a negative number. So that means that all these values here less than -2 aren't in our domain. So the domain is where the graph starts at 2 and it continues on to infinity.